So yeah, I think previously I had said 2 videos coming from my other course, but actually I put in 3. So the previous 3 videos were coming from my supervised machine learning from first principles course here on Udemy, because I wanted to explain exactly what principal component analysis is. The first one of the 3 was just the explanation, and then the second one was an example, and then the third one was talking about scree plots and how it actually does that. So in this video we're just going to continue the discussion. So as you have seen hopefully in the videos, PCA attempts to minimize the reconstruction error during the search of optimum principal components. So back to our MNIST dataset, right? Our MNIST dataset, we have 784 features, right? They are features. When we stretch out an array, they become sort of like features, right? So we have 784 features, or 784 dimensions per image. So we can call them, let's just say, D dimensions. They are D dimensions, right? With PCA, we want to project these 784 into a smaller subspace with K dimensions, right? Where K is less than D. K is less than D. But we want to do that retaining as much information as possible. Retaining as much, that is the constraint. Our constraint is we want to retain as much information as possible. And we said information is also the variation. If you have a column that is high variation, it probably has more information than a column that doesn't have any variation at all. So these K columns are called principal components. The number of principal components we are left with are usually considerably smaller than the ones that we originally started with we didn't start with any principal components. They are usually smaller than the original features or dimensions that we started with in our original data set. And they have information in them, even though they are even though we have a smaller number. We have maybe 20, when yet we started with 100. We still maintain the information. That is a very critical point. We're going to see how right now. In the scree plot we did talk about some of those things, but now we're going to see exactly when it comes to like the coding part. So these ones now, the lower dimension space with these principal components, it makes it easier for us to perform tasks like anomaly detection and clustering, because now we're dealing with a smaller number. The information is still there, hidden inside K. The information, like we said, it retains the information, so we haven't lost out anything, but we have actually gained efficiency. We've gained efficiency because instead of working with 100, we are now maybe working with 20, and our machine learning models are going to smile a bit. They're going to smile because we're working with a lesser number of dimensions. So that's just what I wanted to explain in this video, because in the next one, what we're going to do now is to get into the coding itself of principal component analysis and see the concept in practice. What does it mean when we're coding it in Python? So stay tuned for that video.